Good day, everyone, and welcome to today's DevOps.com webinar. We're excited to be with you. Our topic today is a really interesting one, Git-based security workflows for developers. It's a very timely topic. I'm sure we all have some interesting projects that we're working on while we're working at home these days. My name is Mitch Ashley, and I'll be your host and moderator. Just a few housekeeping items. First of all, we are recording the webinar. So we will send out an email to all participants. You'll receive a link in that email so you can go back and watch. So you don't have to take lots of notes. Matter of fact, I think you may want to even kind of play along, if you will. We're going to have some demos and things to show you that you could actually do yourself. So our folks will tell you about that. We are giving away 4 gift cards, and we will announce that at the end of the webinar, right before we sign off. So please stick around and find out if you're one of our lucky winners. And of course, our speakers love questions. They're going to go through a lot of really cool stuff, and I'm excited to show it to you. And so they really appreciate the questions. So please enter those into the questions tab on the GoToWebinar software. So let's move on to our topic, Git-based security workflows for developers. I'm excited to introduce our 2 speakers. First is Arun Balakrishnan, who is Director of Product Management with Shift Left, and Andrew Fife, who is Head of Marketing with Shift Left as well. I believe Andrew's going to take things first. So Andrew, I'll hand it to you.
Thanks, Mitch. I appreciate the introduction. We're really happy to speak today about something that we're passionate about, which is making application security more friendly for developers. In jumping right in, a couple weeks back, we ran a survey, and that survey was specifically about the nexus between application security and developer productivity. And what we got was a really, really strong result. So we asked about a variety of different ways in which application security might help or hurt developer productivity. And we found that the number 1 response, and with an overwhelming agreement, was that the biggest way to hurt developer productivity was by having disconnected workflows between the AppSec and the engineering teams. And so, in my career, I've run a lot of these surveys. It's really, really rare that you get a result that is this strong. So when we saw the results start coming in and could see how consistent they were, we knew that we really had to react to this. And so that's what much of this presentation is about. It's about where did this disconnect come from, and what exactly can we do about it? So let's jump right into that. So where exactly has this disconnect come from? And we think if you look at the innovations that's occurred in the SDLC and you compare it to the innovation that's happened in application security, we think this is kind of the root cause. So this will probably be a nice quick trip down memory lane for a lot of folks that have been developing applications or securing them for the last 20 years. Not going to jump into every single one of these, but there's been a massive amount of innovation that's happened in the software development lifecycle. And if you scroll back to 20 years ago and you think about what those waterfall release models were, and you think about what the agile release models are today, it's just night and day. People used to release software once a year, once a quarter. Now there are many organizations that release multiple times per day. If we compare this to security, well, there's quite a lot of innovation that actually happened between 2001 and 2003. In 2001, one of the most significant things was that OWASP was founded. It's been an incredible organization that's helped to coordinate and advance application security. And then in the next 2 years, you saw the web application firewall, static application testing, dynamic testing. You saw the modern incarnations of all 3 of those core security tools come out. But unfortunately, since 2003, there just hasn't been the same level of innovation in application security that there has been in that software development. And so what this means is that much of the way in which we think about securing applications is actually rooted in this 2001 to 2003 time period. And if you compare the 2 different lines, there's so many different innovations that have come in the SDLC after that. So what started as a small innovation gap, 15, 20 years ago, has become really, a chasm. And we think that that is one of the core roots of the disconnect. But the title of this webinar, as you can see, we've highlighted here, is really about Git. And when you think about all of the different innovations that are on that have happened in the SDLC, arguably the most impactful one for developers is actually Git. And so what do we mean? Well, the way in which we check in code has changed dramatically with Git. So in the past, what we had was a centralized system where only one person could work on a file at a time. However, in the decentralized model of Git, because every developer can create their own pull request, that's enabled us to move much faster and be much more agile. So we think that that Git is a key innovation in this SDLC that is worth focusing on. Ultimately, the results of all this innovation on both sides have been a disconnect between release frequency. What you're looking at on the left is from our survey. We asked people, how often do you release? And on the right, what you're looking at is the scanning frequency by market share, the largest SAST scanning tool out there. So we think that's a pretty good proximate for average. So if you look at this, 70% of organizations are releasing software multiple times per month. But at the same time, 82% are only doing their SAST scanning monthly or less. So that right there is the disconnect. It's that we are developing and releasing code at a pace at which we're not able to keep up with from a SAST perspective. And this cascades all kinds of problems because now we're attempting to secure code very late in the software development lifecycle after it's already in production. So we could look at what the majority of people are doing. That's one lens to think about this. But another way to think about it is, okay, well, what are the cutting edge folks doing? And if we focus in on let's say the top quintile, actually 18%, those folks are actually releasing every day or multiple times per day. Yet they actually haven't solved the problem either, because if we look at the scanning frequency on the right, you can see that still it's less than 1% that are actually able to scan at that frequency. So this is a problem. This disconnect between releases and scanning is a problem that's pervasive for basically everybody that's releasing code. And we think that it's fundamentally about the model of how software is built versus when and where software is secured. I'm not going to go into detail, in this sort of Git-based software release model. I think everybody's probably familiar with this, and you're probably familiar with how security fits in. So the first step is that the security team is going to run their SAST tool, and then they're going to triage the results. After the results have been triaged, those vulnerabilities get passed over to a development team. So there's two key things that I want you to notice here that are one is not so subtle, the other is a little bit subtle. The first is that this security process is not connected into the SDLC really in any way, shape, or form. So that's one issue. But then the second one is a little more subtle. When you look over here in the development phase of the SDLC, we're talking about an individual developer. And when you look in security, we're talking about vulnerabilities being passed to a development team. So right there, we've actually already created some unnecessary issues because it's hard to tell which developer even wrote the code. Now we actually have to spend time figuring that out. But in addition to that, because it's not connected into the SDLC, and because we know that people are scanning or running these scans on average far after they've released the actual code, what can happen is two things. One, the developer has to do a massive context switch. That code is not fresh in their mind anymore, and so fixing it becomes a little bit harder. But second, because other members of their team are assuming that everything in the master branch is secure, that means that when they do their own pull requests, they are at some point going to be writing code that interacts with the vulnerable code. And so that means when you have to go back and fix that underlying vulnerability, you might actually have to go and rewrite a bunch of code that is, that's interacting with it in some way, shape, or form. And obviously, those are the hardest vulnerabilities to fix. So we also, in our survey, looked at security insertion points, and we looked at which insertion points were more likely to hurt developer productivity. And the really interesting thing is that although the order is slightly different, the top 4 most common places where organizations are attempting to insert security into their SDLC are also the top 4 where developers report that their productivity is lost. So if you look at this bar here, on the first bar here on the left, I think what this is telling us is that developers don't want to actually be bothered with security while they're actually writing the code. The IDEs in general, developers report that they're annoying, that they slow down their machines, and we know that in many instances, developers simply turn them off. If you look at the next most common places where productivity is hurt, you can notice that there's a pattern where there's actually inverse relationship between productivity loss and how late in the cycle the scanning is taking place. So basically, what I would take away from this is that developers want you to scan early in the process, but they don't want you to actually interrupt their process of authoring code itself. So how early can you get without actually frustrating them while they're writing the code? It's not just us that's noticed this correlation. IBM ran a study on this as well, and as you can see here, they have noticed that you get a massive efficiency benefit the earlier in the process that you find your vulnerabilities. However, I would suggest that when you look at what they're doing here, and they're starting from the design process, that is appropriate for some vulnerabilities. Philosophically, it's the right place to be finding and fixing your vulnerabilities. But in practice, so many vulnerabilities are actually about an inadvertent mistake that the developers made, or a lack of secure coding knowledge. So when we're talking philosophically, yes, in the design phase, we can be trying to root out business logic flaws. That's a great place to do that. But practically speaking, when you think about inadvertent errors, or you think about lack of secure coding practices, really much of our focus should be on development. So instead of thinking about this on a scale from 1x to 100, what we'd suggest is think about the gap between development and test. And so this is just simple math here. It's just 15x divided by 6.5. And so you can see that if you can find your vulnerabilities in the development phase before they get into test, before the application is built, you can be 2.3x more productive according to IBM's study. And then if we do that same process, you can see that the gap is even bigger between development and production. So what's the solution? The first thing is, again, harking back to when so much of the innovation in application security occurred in that 2001 to 2003 time period. We have to start realigning and rethinking who's actually using the tools today, because all of the tools were built in 2001 and 2003 for the application security team, and that's appropriate for some of the tools. But we think that some of the tools actually have new users, and so we need to start realigning them. And then once we figured out, okay, what's the right user for the right tool, how can we find a way? How can we find a model that works for that user? And then, of course, once we've found that model, we need to start thinking about what are the requirements to get from where we are today to where we need to be for that new user. So specifically, what I'm saying is that you should be thinking about your security tools on a spectrum for who the key user is. And for many of the security tools that are out there, they remain actually, they should remain security centric. If you think about what a web application firewall and a runtime application self-protection do, they're protecting that application in the production environment, and they do that largely based on how their rule sets are configured and how they're operated. And so the user that is adding the value into that tool is application security. Hence, that should be an AppSec-centric tool. But not all tools are that way. So when we think on the other side of the spectrum, when we think about static application security testing and we think about software composition analysis, the value isn't so much in how they're configured. I mean, sure, there's a little bit of value in the initial configuration, but by and large, these tools are automated. And so it's not the running of the tool, the operating of the tool, it's the output of the tool and what you do with it. And who takes that output of the tool and who fixes the vulnerabilities? It's the developer, right? So in other words, finding vulnerabilities is less value than fixing them. And so we should start to think about these tools as developer-centric, because it's the developers that are adding the most value from that tool. And then, of course, there are tools that are in the middle. So if you think about DAST and IAST, well, yes, the reason why you're attempting to find vulnerabilities with either dynamic or interactive application security testing is ultimately to fix them. There's tremendous value. In fact, when it comes to IAST, really all the value is coming from the test scripts that you're running, right? And the QA team's got to go create those. And if you think about DAST, there's tremendous value in terms of the skill in which you're actually using that tool. And so, these are sort of hybrid tools. So as you're starting to think about how can I make my application security program more efficient, think about who's that right user for the right tool, and then try and build your workflows, with that appropriate user in mind. And so now that we've identified, at least from a SAST and an SCA perspective, that the developer is really who this tool should be built for as the primary user, what can we learn from how developers work efficiently? So let's come back to our Git based workflow, right? What we see is that the developer has a commit, they do a pull request. There is often some automated testing about, in this case, unit testing to determine whether or not they're going to break, the application. And in this case, what I'm signifying with the red is that, yes, this developer's code would actually fail the unit test. So then there's another step, which is to apply a fix. And once that fix works, it then gets merged into the master branch. So when we think about this workflow, what can we learn from it and to apply to security? So first and foremost, and I can't say this enough, developers like it. Unfortunately, there can be at times a little bit of tension between development teams and application security teams. And so getting a process that developers like and that they'll buy into, that's really, really important here. And I wouldn't undersell that at all. Second, the developer never has to leave their environment. It's an easy thing for them to adopt. Not only do they like it, but it's not a lot of change for them. Third, they get that feedback immediately, so there is no context switch. Not only does that mean that the developer can likely fix this vulnerability easier and faster while it's fresh in their mind, it also means that those vulnerabilities aren't going upstream, and so therefore other developers are not writing new code that's dependent on the vulnerable code. The feedback happens when it's most relevant, right? So again, that's early in the cycle, and the feedback is trusted. You don't see big fights breaking out about unit testing. You kind of broke the code or you didn't. As opposed to when you think about vulnerabilities, this entire triage process is really about finger pointing, because we know that historically, unfortunately, some of these tools have had some problems with false positives. So trusted feedback is important to getting people to focus on fixing rather than worrying about sort of the finger pointing of, is this real or is it not? And second, there are standards There are standards that are applied, that the organization has set, that are applied to the individual. And because those standards exist, the individual winds up being accountable for their own code, because this is all happening in their own feature branch, right? It's very clear that whose code broke the app. And then lastly, over time, what you see is that developers who tend to be very intelligent people, and they tend to be very rational people, and they tend to like efficiency. Well, that means that if they know a certain standard is going to always be enforced every time that they're going to attempt to merge their code into the master branch, they're going to adapt their coding styles to meet that, so they don't have to deal with applying new fixes. So in other words, the standards that apply ultimately teach the developer something about how code should be written in that organization. All right. So with that being said, we wanted to show you an example of how exactly this can be applied. But one thing that we haven't said is that developers also tend to like to try things for themselves, to test things out. And that's a really important part of, we think, designing a tool for them. So one of the things that you're going to see from us here is how easy it is to get up and running and test this out. So with that being said, I'm going to pass the torch over to my colleague Arun, and he will walk you through a demo. All right, Arun, you should have it.
Okay. Andrew, you can see my screen and hear me well?
Yep, we can. Okay,
perfect. So yeah, thanks, Andrew. And so for the demo, just to touch on a few of the things that Andrew spoke about in the workflow, let's see that in action with one of my test repos. So what you see here is GitHub, right? I've got a JavaScript app, a demo app, which has known vulnerabilities in it. And let's see how a developer would go about modifying some source code, and how do they get feedback by using shift left. So let me start with one of the source code. I've got a JavaScript file here, and what I've done is I've purposefully commented out a couple of lines in this, and I'm gonna uncomment it. So here, this line, right, this is commented out. This is a key that I'm gonna use to access my mail server, right? So bad practice, I'm hard coding it directly into the source code. That's first mistake. And even beyond that, I'm also going to now write it onto the console while the application runs, right? So I could say that, okay, it's hard coded in my source code. People don't have access to my source code. But the second thing is, if I'm putting it onto the console, well, I can't control who is then seeing it. So I'm introducing these two issues into the source code. And this would be a part of a bigger change, but for this demo, I'm just going to make this one change. And I'm going to create a pull request saying, hey, I want to make these changes to this file. And since it's a single file change, I'm going to just create the pull request here without adding more commits. So one thing you can notice, as soon as I created the pull request, I'm also using GitHub Actions within GitHub. So that's my CI system here. So as part of the pull request, I've asked GitHub saying, build the source code, because if the code doesn't build, well, I shouldn't even be sending it out for peer reviews. And in addition to it is this step here, right, wherein shift left will be invoked as part of this basic checks for every pull request. Now, here what you can see, so if I go into the details, so it's all happening within GitHub Actions, as I mentioned. So it's doing all of this, wherein it's pulling the code, it's trying to interpret it, it's JavaScript, so it's trying to interpret it, see if that code is syntactically correct, if I have made any syntax errors or stuff. and then it is performing a shift left static analysis. Now, it should take maybe less than 2 minutes, and I think it's complete. Yep, that's it. It's complete. So it took all of 1 minute for that entire analysis to be done. And when I go back into that conversation window, so one thing to notice, I've not left GitHub at all, right? I'm still in my workflow. I'm still in my code repository. And then I made the pull request. I'm in the conversation window for the pull request. And here it immediately says shift left next-gen SAST found hard-coded secrets in your code. So this is direct feedback in the pull request. Now, two benefits to this. One, of course, I get to see it immediately, right? Within a minute of me making the code change. And second is in most organizations, if not all, reviewers are involved whenever a code change is made. And when a reviewer comes in, this is including code that we develop here at Shift Left. When a reviewer comes in, this is the window or the view that they also would see, wherein they would get a notification that, hey, one of your peers have made a code change, they've created a pull request, and they're asking for your review on it. Now, when you go in and you're seeing this, you would see that, okay, these are the files that are modified. You see the changes, you see the conversation window, and you see that, oh, Shift Left's found a vulnerability, and you see that no code changes were made after that, right? So the vulnerability still exists. And as a developer, then I get the opportunity to fix this even before the reviewer gets to see it. So then what it would look like is there'll be a few more lines here wherein it says code again changed, Shift Left didn't find any issues, and it says the statuses are passed and merge is allowed. Right? So then the reviewer can come in and automatically see that, oh yeah, Shift Left found issues, the developers fixed it. So I don't need to think about those security aspects. Let me look at the code for any bugs or for any functionality issues. Right? So this is from the workflow perspective. Now, so there is this information here, right? Now, to look at more details, I just need to click on this link here, and it directly takes me into our portal, that's shiftleft.io, and takes me to the details saying, in mail.js, on line number 25, we see that this secret was hard-coded. And why is it a problem? What is the recommendation, right? And here we can also start doing some collaborations, wherein if the reviewer is the one who came and saw this, or if, say, I am a person who didn't write this line of code, like I just pulled a file, somebody had made this issue, they didn't fix it, I can then start assigning it. I can assign it to other people in the system. It then goes there. If I've integrated this with things like Jira, it can be integrated there. I can send it directly. And if it's fixed there, it will reflect back as fixed here. So all of those integrations are also possible. So you can see that this entire workflow can be done completely. Two things to note, if I go back to the pull request. One is the speed at which it was happening, right? Like as soon as I made the change, within a minute, I get immediate feedback. So that is one. And second is I literally didn't even click a button saying scan this code or show me the results. It's all completely automated and as part of the process, right? So that makes it easier for developers to use, right? This is not an additional step that they would have to invoke or send it out for scanning somewhere. It all happens within the workflow. So that's with the PR workflow. And this is a simple example, right? So I've got another one here as a complex example where it does a lot more things because that code had a lot more vulnerabilities. So like SQL injection, sensitive data leaks. So all of those are also found by our software. And now let me switch gears into how easy it is to integrate in the first place. So as Andrew was mentioning, developers like to try out stuff. So if you go to GitHub Marketplace, you search for Shift Left, our app is deployed there. So it's easy to set up. It's literally clicking this button. Or if I were to go back into my dashboard, let me go into my details here. Okay, right. So this is the application that we just scanned. So if I go back to applications and add app, it is already tied into my GitHub, right? So when I select the access that I need to grant, it pulls my repositories from GitHub. So I can just say click, click, and I click next, and it just starts scanning those apps. Right? So it's that easy to start scanning. Let me show you a couple more things, and then I'll pass it back to Andrew. So this is the demo app that we just saw. And it does find more things. So like secrets is what we were looking at. So this is the one that we just found, wherein it says, okay, hey, this is a key. It's an API key. It is related to Mailgun, and it is related to infrastructure as a service issues. So this is the classification we have. And you can, of course, collaborate on the other features that I was showing you. But it does other things also in this application. Right? For instance, in this security insights one, there are other issues that it finds, wherein it says, hey, okay, I see that you're using this function for regular expressions, and it's known to be not a safe function. Like there are safe alternatives to this using the safe regex module. If you use this, you are susceptible to denial of service using regular expressions, right? Because depending on the regular expression that comes in, you could go into an never-ending loop which eats up your compute and memory resources. Right? So it does that. Of course, this is JavaScript, but then I also have other applications here. So this is a Java application, for instance, where it does a lot more types of vulnerabilities in this sample code. So like cross-site scripting, SQL injection, all those. And then on the right, what you notice is a complete data flow of how it happens, right? So starting from the specific line of code, and if I click on this line of code, it'll take me back to GitHub, exactly to that line where the issue is, right? So this is again complete workflow where I find an issue, I can click on something, I can go directly to the line of code, I can then edit it right there. It'll again scan, it'll again show me if the vulnerability is fixed or not. And so the developer they're not switching focus, they're all doing it within the environment they're used to. Yeah, I think I covered the things I had planned to. Andrew, let me pass control back to you.
All right, thank you very much. All right, so that's the way in which we have designed Git-based workflows for developers, and we're quite proud of it. But what we're really proud is the reaction that the results that we're driving for our customers, and what some of our customers are saying about this. So if you're a soccer fan, or if you fly in and out of Europe and the Middle East a lot, you're probably familiar with the Emirates Group. You might recognize the Fly Emirates logo that is on a number of European soccer clubs' jerseys. Emirates is actually quite a bit bigger than just the airline, though. In fact, they've got, I think it's now over 28 billion in revenue and 105,000 employees. So not a small organization. But as you can see, what their VP of cybersecurity said about implementing this model, he said, by scanning every pull request, our software engineers are able to fix vulnerabilities far more efficiently. Not only are we seeing month-over-month decline in MTTR, but it's now common for vulnerabilities to get fixed in the same sprint they are found. And most importantly, our engineers really like the process. So I know for me, there's the data, but there's also the emotion. And so I was really pleased to hear him want to talk about how their engineers like the process. In terms of hard results, what we're seeing across our customers is that when you fix that disconnect, when you go from scanning on an ad hoc basis, which we saw, 82% of the market does less than monthly, to scanning every single pull request, what happens is that you massively increase your scan frequency. And so what we're seeing across our customers is 110x increase. which is pretty cool. But again, as I said, it's not really finding vulnerabilities, it's fixing vulnerabilities. So we're much more proud of these other stats. And the big one is that because we're doing this scanning at the right time to the right person, in other words, the right developer gets the right vulnerabilities at the right time, we're seeing a massive 5x reduction in MTTR. Also, we're seeing that the vast majority of vulnerabilities get fixed before they're released to production. And even a number of vulnerabilities get fixed literally the same day. So we're very proud of all that, and as such, and as Arun showed you, and I think you got the link, we have made it incredibly easy to try. If you click that link that we sent, you go to the GitHub Integrations Marketplace, you can get Shift Left up and running literally with one click. All that you're going to do is click that link and then select the repo you want to scan, and literally in under 5 minutes, you're going to have results from deployment to results. But so when you think about it, as you're starting to build your own developer-centric security workflows, the requirements that we think you should keep in mind are, first and foremost, remember that this is something that we're building for developers. And so instead of taking something that was built for application security and trying to adapt it, what we would suggest is rethink and build your new workflow with the developer's needs as the primary needs, right? Don't adapt something from someone else's needs to the developer. To put the developer as the first principle, and if you need to do a complete rethink, we think you should do it. But also keep it familiar, right? Developers, they want to spend more of their time, writing new code, and frankly less of their time securing their code. So do it in a way that they're going to be more likely to accept. And while I know in our case we have put a lot of time and effort into trying to figure out exactly what we think the right Git-based model is, we know that every organization does things a little bit differently. So we built our app with really, really robust APIs so that you can dial in the way in which Shift Left works exactly to the needs of your organization and your teams. So those are 3 important things to be looking for. But there's a couple of technological precursors that you really need to have in order to be able to implement something like this. We talked about how in the feature bug model with unit testing, you get that immediate feedback. Well, that's really about scanning speed. And the industry average is around 100,000 lines of code per hour. So if you've got an application that's a couple 100,000 lines of code, or even if it's 50,000 lines of code, you're talking about adding some serious delay into a pull request. We don't think developers are willing to wait more than a few minutes. And really, if you can provide that, bam, immediate feedback, that's the best. So you need something that's really, really fast. And I would suggest that you're going to need something that is going to be able to scan, I would say, around 250,000 lines of code in 30 seconds. That's sort of a good benchmark to start looking for. But it's not just the actual scanning speed, because if you think about this 110x increase in scanning frequency, a lot of the ways in which our SAST tools are set up, they're on-premise hardware based, and we're paying a license to scan one at a time. So if I'm taking something where I was scanning, a couple times a year, maybe once a month or less, and now I'm increasing the frequency 110x, well, gosh, I'm going to hit some pretty severe, hardware and licensing bottlenecks. And if you get into that mode where you start having to queue, well, you're going to have a compounding effect on your speed, and something instead of taking hours with the the compounding effect of the queue could easily be days. And really, as I said earlier, we think developers, you're pushing it to make a developer wait even a few minutes. They want that instant feedback. So be thinking about speed as a precursor to doing this model, but think about the potential for creating bottlenecks, not just scan time. And then, of course, it's accuracy. If you are giving developers immediate results, but they're all false positives, well, they're going to quickly learn that this is a waste of their time, and they're going to reject it. So what you want to do is you want to figure out how you can earn their trust by giving them quality results, but also, hey, let's not waste the developer's time with a bunch of stuff that isn't relevant. And then how do you dial your accuracy in even more? Well, one of the key things is that enable your developers to be able to teach the tool. Now, you might want to have some security oversight. You don't want to necessarily enable a developer to ignore SQL injection vulnerability, but you want to be able to take their feedback and react to it so that the tool can get even better. And once you're delivering immediate results and those results are trusted, now security, we think, has earned the right to come in and actually enforce security standards right there in the pull request through build rules. So what we're saying is that whether it's the vulnerability severity, the volume of vulnerabilities, the type of vulnerabilities, the age of vulnerabilities, security should be able to enforce that organizational standard, whatever it is for each organization or each team or even each application, but enforce that to all individual developers. And what starts to happen now is we create a system where there's accountability for the individual developer to secure the code that they wrote. And of course, you got to be able to do all of this stuff without cutting corners. When you think about it, the biggest way in which a lot of vendors are attempting to cut corners is trying to get around some of their speed limitations. And the way in which they do that is by delivering an incremental scan rather than a full scan. So if you think about what most vulnerabilities are, most of them are related to data flow. And so you need to be able to understand the full route from source to sink and all the transforms that are happening in between, to the data along the way. And so as you start to do incremental scans, you're not necessarily looking at the full route. And so you're creating false positives and false negatives. So we think it's really, really important that you're doing a full scan and not an incremental scan. In other words, if you're cutting that corner to try and deliver on speed, you're just going to be hurting yourself more severely in other ways. In addition to the full versus incremental, a lot of the tools out there do a reasonable job on OWASP top 10. Not a lot of people that are missing, the big ones like cross-site scripting or SQL injection. But what we hear today in the headlines is so often inadvertent data leakage or business logic flaws. And those are vulnerabilities that SAST tools really struggle with in general, because what SAST is ultimately doing in most cases is looking to match patterns. It's written a query that is testing your code to look for conditions that might lead to SQL injection, right? And there are certain conditions such as lack of sanitization or lack of validation that could lead to SQL injection in anyone's code. So there's a pattern to match. But if you think about business logic or you think about data leakage, those are elements that are unique to everybody's code. No two applications have the exact same business logic. So therefore, if you're taking a pattern matching approach, it becomes very hard to identify business logic flaws. Similarly, when you think about data leakage, how does a SAST tool know which data is critical? How does it know what the appropriate handling for that data is? How does it know, what the right encryption strength is for your organization? It just doesn't know those things. So those are some things that you need to consider as well. And with that being said, we've come to the end of our presentation, and we would love to jump into Q&A. As Arun mentioned, as I mentioned earlier, we do offer everybody free shift left accounts. It's not a free trial; it's free forever. There are some limitations, obviously, in how much scanning and how many lines of code you can do, but it's very usable for a small team to use indefinitely. And for a larger team, it's a great way to see if this model is appropriate for your organization. Now, if you are a GitHub user, you can find it in the GitHub marketplace and start using it right away. If you're not a GitHub user and you want to insert into GitLab or Bitbucket or a CI tool, we've got integrations with plenty of those. You can create your account at shiftleft.io/register. So we will we've already shot you the GitHub link through the chat, but we'll shoot you the shiftleft.io/register link through the chat now as well. And with that being said, we will jump into the questions. Give me 1 second to get reoriented here. All right. So the first question here is, there's a tension between getting feature branch merged quickly versus getting only quality code into the master branch. My experience has been developers prefer to stay too long in the feature branch. Adding more steps there makes the merge to master too long. If I understand the question correctly, we certainly agree that developers are not willing to wait, and that you can't add significant time to this process. Hence the emphasis on speed. But if I've misinterpreted your question, please feel free to re-ask it, and we'll do our best to get to it. Okay, and actually I see a little later it says my limit is 10 minutes for developers, and actually scanning speed of 1 minute is reasonable. Yeah, that's kind of what we think as well. Next question here says, Arun, this is a good question for you. I'm not sure of the answer here. Is there any possibility to hide the vulnerability if it found secrets not to be shown in the Shift Left app, as I wouldn't wish to share the external app to read the secret or the business info?
Yes, so for the demo reasons, I used it where it's not configured in that way, so it shows up. But yeah, it can be obfuscated. We don't want to be, we don't want our systems to be also holding your secrets because now it's there in 2 places. So yes, totally agree.
Okay, there's a couple of questions here about language support. We're asking, do we support Python? Arun, do you want to take that one?
Yes, we do. So if you go up and sign up on GitHub or the registration page that we sent, you can see the languages we support. Or maybe when I was showing the demo, I showed you a list wherein there's Java, .NET, JavaScript, Python, Scala, Terraform, Go. So there's like a list of languages that we support, and we keep adding more languages as we go along. So yeah, Python is definitely supported.
Okay. The next one is, you mentioned scanning in the Git repository, but you also mentioned that you have integrations with CI tools. What's the difference?
Okay, so so in the Git repository, when I was doing the scanning, I was actually using GitHub Actions as the CI system. Right, so our integration point is into continuous integration platforms. So Jenkins, Circle CI, GitHub Actions, Bitbucket pipelines, wherever you build your code is where we integrate into. So yeah, and then as Andrew mentioned, with GitHub, it's a single-click integration. That doesn't mean it is difficult to integrate with any of the other tools. If you go to our docs website, which is public, at docs.shiftleft.io, you can see a long list of CI systems where we have step-by-step instructions. And literally to initiate the scan, it's just like 3 to 4 lines of code, wherein you get the authorization tokens, and then you invoke Shift Left with a single command. So it's very straightforward.
There's another integration here. It says, which trouble ticketing tools do you integrate with?
So yes, out of the box, we integrate with Jira. That's the most common one we get as requests from customers. So that's a straightforward click integration. And then once integrated, you can send issues into Jira. And it's 2-way in the sense you can update status in shift left, you can update status in Jira, so it will reflect on both sides. So that's one. That said, as Andrew was mentioning in his slides, our UI is built on top of our public APIs. So everything, literally everything that you see on the UI is accessible over our public API. So we do have customers who have in-house systems. These are not even commercial off-the-shelf software. So they take input from, or they just integrate our APIs directly into those tools, and you can do integrations that way as well.
And actually, the next question was about APIs, and the question is, do you charge for API access?
No, absolutely not. Yeah, we know of other vendors who do charge extra for API access, but no, this is part of your package. Yeah, we don't see like nickeling and diming in that sense making any sense. Developers need API access to make this work for them. Even some of the output that I was showing you, wherein we can see the direct link to the vulnerability that is coming within GitHub itself, all is based on our APIs. So yeah, it is totally part of the software.
Just got another question here. It says, have you been highlighted or discussed in any Forrester or Gartner research? The answer to that is yes. Shift Left was named a cool vendor by Gartner. And in the Gartner, just I think it was last week, released a new set of hype cycles. And if you look at the DevSecOps hype cycle, we are listed there as an example vendor. So yes, we've been mentioned in Gartner research a handful of times. Yep. And that is all the questions that we actually have at the moment. So if anyone else has a question, please ask it now. Otherwise, we will move on and do some of the housekeeping items. I think that Mitch has. I think Mitch, you have a raffle. Is that right? Mitch, I think you might be on mute. Well, while we're figuring out what's going on with Mitch's audio and the raffle, Arun, are there? I'm actually curious. I don't know the answer, but are there some creative uses of the API that you've seen in Shift Left customers that you think are worth highlighting? And that might be a tough question, but what are some of the most common ways in which people use the API?
Oh, sure thing. So yeah, we have a couple of customers who like this is a tool which is very different from what they're used to, right? So Andrew, some of the points that you highlighted of like mean time to remediation, how quickly are vulnerabilities being found and remediated. A couple of the examples that you gave, which are average, but the distribution is not wide. So most of our customers are experiencing the same results, wherein vulnerabilities are being fixed the same day or within days. These are all some kind of interesting analysis and things that the teams that purchased us want to highlight to their management. So they're doing, since our information is all accessible over the APIs, which even includes things like, okay, what is a vulnerability? What type is it? Criticality? Where was it found? When was it found? Did it get fixed? Did it reappear? Was it a regression? So all of this information is available over the APIs. And so I've seen a customer who is churning this data in multiple forms, not just highlighting the value that we at Shift Left are providing, but also how their developers are becoming more productive and how it is making the security program stronger. Right? So, and based on this, we are realizing, okay, maybe these are some things which other customers might benefit from, but they might not have the time to play around with the API. So we are working on enabling these as reporting. So it's like single click, able to get these out as a report versus having to write your own scripts. But yeah, that's one interesting use case that we encountered.
Okay, and it looks like we just got one more question. It is, excuse me, it's is the cost of this tool, if an organization decides they would like to enable the entire dev community? I'm not sure I completely understand the.
And Andrew, I think she followed up saying, is there a cost to this tool?
Oh, okay. Yes. So we have, we're a very transparent organization, and our pricing is listed on our website. If you go to shiftleft.io, under the products tab, there's a page called pricing, and it's a per developer cost. And so the free version is free forever, but it does have some usage limits in it. And so if you're a large organization and you want to go organization wide, the pricing's right there. And if you want to do, of course, as with most B2B vendors, if you need help from us to test it, in a larger sense, we're more than happy to work with you on a proof of concept. And then it looks like we got another question here that says, are there tutorials to follow on? We certainly have had a partnership with DevOps.com for a long time, and so I know that we'll do another webinar in about a month. In terms of what that topic will be, we haven't actually decided quite yet. But what I would say is that if you're looking for help, if you want to try this out in your organization and you're looking for some help, just reach out to us. Like I said, we're more than happy to work with you on a proof of concept basis to make sure that this is the right tool, for you. So I guess technically there isn't a tutorial that we're going to follow on, but we're happy to give you some one-on-one help. And in addition to that, we've put a big effort on making sure that we've got great documentation. So docs.
And Andrew, I would add that the docs are it's public. So docs.shiftleft.io, you can go in and check it out yourself. And there are like quick start guides. There are we are not doing a live tutorial, but there are tutorials in the docs which you can follow by to analyze applications, customize your results, do custom policies, look for specific vulnerabilities. All of that is documented in the documentation and easy to follow.
Yep. Well, so we've got 2 minutes left here, and I've gotten a note from the panelists that we do have winners for the raffle. Sorry for the delay in keeping you folks. The winners are Blanca O, Danielle P, Jeremy M, and Mike P. And the team from DevOps.com will follow up with the winners via email so that you can get the gift cards. Yeah, and again, if you have any additional questions, feel free to reach out to us directly. Probably the best way to do that is you can certainly email me. I'm Andrew at shiftleft.io, or if you'd rather, on our website we have a contact us form. I guarantee you we read every single one of those. So feel free to get in touch, and please do try the free version of our application. With that being said, it's been a pleasure to talk to you guys today. Hope you have a great rest of the day. And we'll look forward to chatting again, either directly one-on-one or in our next webinar. Thanks again. Bye-bye.